Dear students, in the previous session of module 3, we have discussed regarding the effect due to climate and also temperature. Now, in this session, we can discuss some more things, that is effects due to chemical, effects due to wear and erosion, and effects due to design and construction error. Okay, this is coming under the syllabus of module 3, that is influence on serviceability and durability. After listening to this session, the students can understand what is the effects due to chemicals and what is the effect due to wear and erosion and what is the effects due to design error. We have already discussed the chemical causes of the deterioration of structures in the first model. Some of the things we are going to refresh, or we are going to discuss some more things with respect to the chemical causes, okay, which affects the serviceability and also the durability. Okay, just let us see what is the effects due to chemicals. So some of the factors which influences the vulnerability of concrete to external chemical attack, that means the external chemical attack we already discussed regarding this. These chemical causes such as acid attack, sulfate attack, alkali reactions, all these are from the chemical causes. So by the chemical causes, actually what happens to the structure, that is high porosity and high permeability. Okay, that means as because of this the porosity will be increases and the permeability of the concrete will also increases. We know the permeability of the concrete increases, automatically the unwanted things can enter the concrete elements, so that the chemical causes will be more. Next, improper choice of cement type for the conditions of exposure, inadequate curing prior to exposure, exposure to alternate cycles of wetting and drying, and to a lesser extent heating and cooling with allowance for the fact that higher temperature increase reactivity. Okay, these are all some of the effects due to the chemical. That means the type of cement what we have to use, that should be in the good condition. Next, inadequate curing. If we are doing the inadequate curing before to the exposure, what happens automatically? The cracks will generate, that is shrinkage cracks will develop, so that automatically the unwanted things from atmosphere is enters into the structure elements, which causes the chemical attack. By, for example, the carbon dioxide and oxygen is enter into the structures, which causes the chemical causes. Next, which increases the fluid velocities. Once again, as the moisture is enters into structures, the velocities of the fluid will also increase. Next, the suction forces, unsatisfactory choice of shape and surface of volume ratios of concrete sections. This is some of the effects due to the chemical and some of the factors. Next, coming to the effects due to wear and erosion. First, let us see what is the meaning of wear and what is the meaning of erosion. So, wear refer to wearing away of the surface by friction. That means the wear out. We are assuming that the surface is wear out. Okay, this is nothing but the wear. Actually, what happens due to the frictional force, some of the top surface will be wear out. Okay, for this we are calling as a wear. This is due to the, for example, when the vehicles is moving on the pavement, what happens, the frictional force will develop. For example, if the driver applies the brakes, what happens, there will be frictions develops between the tire and also the pavement. There actually the friction will develop, that causes the wear of the pavement. So this is the one of the example what I am giving. Next, erosion refer to the wearing away of the surface by fluids. That means the surface which is erosion, okay, the surface will take erosion by the fluid. For example, if the water is continuously flows, we can observe in the river and all, what happens, the small stones which is on the smooth surface, that is because of the erosion. That means because of this the erosion, generally in the spillways this type of erosion will occur. Next, the progressive loss of mass from a concrete surface can occur due to the abrasion, erosion, and also the cavitations. Next, the symptoms of this wear and erosion. Just let us go through this. Concrete surfaces operated by waterborne debris are generally smooth. We know in the water, as I said, in the waterborne debris, what happens, that will create the smooth surface to the and may contain localized depressions. Debris remaining in the structure will be spherical and smooth. That means, for example, if you assume a spillway, if continuously the some of the debris which flows along with the water, okay, that movement will take place along with the water will cause the smooth surface. Okay, this is the symptom of the erosion. Next, mechanical abrasion is usually characterized by long shallow grooves in the concrete surface and spelling along monolithic joints. Next, how can we prevent this wear and erosion? We have to design it properly. That means we have to assume this type of causes while design itself. That means you have to consider while designing the structural elements, and in the operation time also we have to be take care. If there is anything we have to do immediately, we have to take necessary action such that to avoid the wear and erosion. Next, we have to use the steel fibers in concrete matrices. We know how actually the steel fibers will be used nowadays, so we have to use the steel fibers. Next, aggregate should be wear resistant. That means the concrete aggregates what we are using for the to produce the concrete should be wear resistant aggregates. Next, the shape and texture of the aggregate plays an important role in the abrasion resistance of the concrete. This we have studied in the concrete technology itself. More the compressive strength of concrete, higher is the resistance to wear and erosion. That means we have to use the compressive strength more. If the compressive strength of concrete is more, automatically the wear and erosion will be reduced. So this is how we can prevent the wear and erosion. Next, effect due to corrosion. So just let us see what is the corrosion. In the next we can discuss regarding the mechanism and how to prevent the corrosion in the structures. So just let us see what is the effects due to corrosion. First, let us see what is the corrosion. Corrosion is the conversion of iron in its oxides and nitrates into the presence of oxygen and water. That means we know the while producing the steel, okay, while producing the steel or reinforcement, so many oxides are mixed and ultimately the iron will be developed. Here, that is the reverse portion, that is corrosion is nothing but the iron is converted into various oxides, so that loses its strength. That is the meaning of the corrosion. So corrosion can be defined as the process of deterioration and consequent loss of a solid metallic material. That means as the corrosion develops, automatically what happens, the solid metallic material will lose through an unwanted chemical or electrochemical attack by its environmental starting as its surface is called corrosion. Thus, corrosion is a process of reversal of extraction of metals. So, some of the influencing factor because of the corrosion. So, the environment to which the structure is exposed. That means in how actually the corrosion will influenced. So, by where in what type of environment we are constructing the structure. Next, what is the cover thickness we are giving? We know in the bad environmental site conditions we have to give more cover thickness. So if we provide the more thickness, some percentage of the developing of the corrosion we can avoid. That means the uh, unwanted, that is moisture or carbon dioxide entrance will be reduced. Next, quality of the cover concrete, so that we should not neglect the quality of the cover concrete. Next, what is the type of steel? So for example, nowadays we are having the corrosion resistant steel and all, and we can use the stainless steel or galvanized steel like that to where the building is constructed in the corrosion influencing sites. There we have to use this type of steel. Next, presence of cracks. That means there should be no presence of the cracks. That means if we have to do the proper compaction and we have to do proper curing, thereby we can avoid the shrinkage, cracks and all. This how we can reduce these are the some of the factors which influence the corrosion. Next, let us see some of the corrosion protection techniques. So coating to reinforcement, galvanized reinforcement, improving metallurgically, using stainless steel, using non-ferrous reinforcement, using corrosion inhibitors, coating to reinforcement, cathodic protection, electrochemical chloride removal, and improving the cover concrete. These are the some of the corrosion protection techniques. So coating to reinforcement is nothing but some of the coat has to be applied to the reinforcement to avoid the corrosion. This is the meaning of coating to reinforcement. And galvanized reinforcement is nothing but the zinc coat is applied to the reinforcement, which reduces the which avoids the corrosion of the steel. This is the meaning. Next, improving metallurgically. While production in the production stage of the steel itself, the metallurgically we have to improve some of the metal to avoid the corrosion. Next, we can use the stainless steel or we can use the non-ferrous reinforcement, and we can use the some of the corrosion inhibitors. That means some of the chemical admixtures which is introduced in the while mixing the concrete so that it avoids the which avoids the corrosion. Next, we can do the coating to concrete also. Next, cathodic protection, electrochemical chloride, and improving the cover concrete. That means the cover concrete should be in the good quality. Next, in the next session we can discuss regarding how actually the coating will be done and some of the methods of the corrosion protection techniques. So in this session, so just we are seeing what is the actual corrosion protection, what are all the corrosion protection techniques we are having. Next, coming to the design errors. So this also we have discussed in the first module, that is inadequate structural design. That means the inadequate structural design, poor design details. So for example, if we are giving the drawing sheets to the site conditions, the if there is a poor design details, okay, for example drafting mistakes will be there and no proper visibility of the sheets, all those things will creates the problem in the site. Next, abrupt changes in section, that means immediately the sections will be changes. For example, a column section will be changes for all floors, that are the beam section will be changes then and there. These are all belongs to the abrupt changes in the section. Next, insufficient reinforcement. Say we know the sufficient reinforcement according to the calculations we have to give. Otherwise, that will become insufficient reinforcement. That is also a design error. Next, inadequate provision for deflection. That means according to code of provisions, we have to allow the beams or slabs for the deflection or flexural elements to the deflections. Next, inadequate provision for drainage. If there is any water is coming on the structure elements, we have to do the proper provision for drainage of that. So all these things we have to take care while designing the structural elements of the structure. Next, insufficient travel of expansion joints, incompatibility of material. This is one of the main thing. It is there should be, as we know, concrete is a heterogeneous material. Okay, that means the so many materials are used. For example, we are using water, cement, sand, aggregates, and some of the admixtures, mineral admixture, chemical, all these are different. Ultimately, after mix, we are there will be compatibility between those materials. Otherwise, the debonding problem will be there. So we have to select the material such that it should be compatibility. Next, neglect of creep effect. That means we should not neglect the creep effect deflections also. Next, rigid joints between precast unit and inadequate joints placing in slab. These are all some of the design errors. So you have to take care while designing the structural elements. So as the physical and chemical causes, the design errors is also very much important. Otherwise, for example, if you are giving the insufficient reinforcement, what happens, the deflection will be more, and for example, if you assume the less magnitude of force, what happens, magnitude of load, what happens, automatically the if the more load is applied in the site conditions, automatically the structure will face. So while designing the building itself, we have to be very careful. If all this, we have to consider all these things while designing the structures. So in this session, in this particular session, we have discussed regarding the what is the chemical effects on the serviceability and durability, wear and erosion, design and construction errors, and also the corrosion. That means what is the meaning of corrosion and list of corrosion protection techniques. So this is in this session. In the next session, we can discuss regarding the what is the effect of cover thickness and cracking. Okay. With this, I am going to close this session. In the next session, we can continue with respect to the cover. Okay, effect of cover. Thank you.